Alright, so we're starting on more formulas. This is from 7.3 in your book, just in case you quickly missed that there. Yes, more formulas to remember. Um, really, best advice, just practice using them. It's really the only advice I can give. So anyway, objectives. You will learn and apply the double angle formulas, and you will use the double angle formulas to prove identities. So let's start with what they are. So your formula for sine, you only have one. Sine of 2x equals 2 sine x times cosine x. The reason you're going to see 3 for cosine is really, this is the main one right here. Okay, these other two can be derived from that. So you've got cosine 2x equals cosine squared x minus sine squared x. So now if you replace if you replace cosine squared x with 1 minus sine squared x minus sine squared x. So basically we replace this with this because of the Pythagorean identity, and then combine like terms, you get this. If you do cosine squared of x and you substitute sine squared of x with 1 minus cosine squared of x, you'll see that you get the same thing. The negative distributes, making that positive, so you get a positive 2 cosine squared of x minus 1. So that's how you get those, and then here you have your tangent. Tangent of 2x equals 2 tangent of x over 1 minus tangent squared of x. More formulas, I know. You guys love them. Alright, so all of the double angle formulas can be derived from the addition formulas that we learned in 7.2. So if you figure out how to do that, it makes your life a little bit easier, a little bit less to memorize, but it is time consuming. So I think you're going to find it in your best interest to just get to know at least, the sine, the cosine, and the tangent, and you can derive the other two cosine from that. However, you need to be able to recognize them as well. And then all the previous formulas that I just showed you can also be verified by working one side of the equation to get it equal to the other. Alright, so let's put it into practice. Cosine of x is negative 2/3 and x is in quadrant 2. Find cosine of 2x and sine of 2x. Now, we're going to start using a double angle formula for cosine, not because they asked us for that first, but if you look at the formula for sine of 2x, we don't have sine of x to plug in there. We don't know it. So we first need to work on the cosine one. So because we don't have any of that, we're going to use the cosine formula that has no sine in it. So we're going to do cosine of 2x equals 2 cosine squared x minus 1. Thing to keep in mind here, this is the same thing as this. Be aware of that. Alright, you've learned it before, this is just a refresher. And why am I saying that? Because you know what cosine x is, you're told it. It's negative 2/3. So we just plug that in for this and square it, which is going to give us, for some reason it's not showing up now. So what's going to happen there is negative 2/3 squared is going to be positive 4/9 times 2, which is going to be, and that's still minus 1, so that's going to be 8/9. Really writing that. So that's going to be 8/9 minus 1, so you're going to have negative 1/9, which will pop up here in a minute, I'm sure. So that was the reason I was showing you that first part, is cosine squared of x equals the same as quantity cosine of x squared. So let's go ahead and get everything up there and I'll walk you through it. So this right here, this answer that we got is cosine of 2x. So you can see I took negative 2/3 because I was told this. Plug the negative 2/3 in here. Minus 1. Simplify it down, negative 1/9. Pretty easy. Now, to use sine, I first needed to find what sine was. So you have this. This is right here. This is a Pythagorean identity. Okay, because remember sine squared x equals 1 minus cosine squared x. So sine x would equal the square root of that. Alright, so what we're going to do, this is all going to be back. We're going to take the square root of 1 minus, we know what cosine is again, negative 2 over 3. We're going to square that. So 1 minus that gives me plus or minus the square root of 5 over 3. Now, this is where this comes in. We need to know whether to use plus or minus. Alright, since it's in quadrant 2, sine is positive, so we use positive 5 over 3. So now we go back down to here. 2 times root 5 over 3 times negative 2/3 gives us an answer of negative 4 root 5 all over 9, and that is your sine of 2x. So these are your two answers. This is your cosine of 2x, this is your sine of 2x. Now, proving identities using the double angle formula is very similar to what you've been doing. It's just a matter of kind of like changing what's on there to get it to match what you want it to. So in the next example, you're going to see that you can write certain trig functions so that we can use the double angle formula. So it may not be as apparent, but you can rewrite it so that you can use it. So, and again, write down each step and work only one side. You're going to get really confused if you try and work two. So let's write cosine of 3x in terms of cosine of x. So to do that, I can use my addition formula. So I can break that up, because remember our addition formula from the last chapter. I'm going to write as cosine of 2x plus x, which allows me to write it out like this because of that addition formula, to expand it, because I've got addition formula for cosine. And then what I'm going to do is, notice now, by using 2x to split it up, look what I did. I've got sine of 2x and I have cosine of 2x. So I can replace those, 2 cosine squared of x minus 1, and then the one formula for sine x, 2 sine x, cosine x. And why did I use this one? And the reason is because it told me to write in terms of cosine of x. So why would I use anything that has sine in it when I've already got cosine? So I did that using the double angle formula. Then all I did was simplify that. So I distributed the cosine of x throughout that and the sine of x throughout that to get, so cosine of x times cosine squared of x, cosine cubed of x, and the 2 in the front. And then cosine of x times negative 1, negative cosine of x. You get the idea. So that times that, that times that. And basically we expanded there. Okay, and then what we did here, we used a Pythagorean identity to get rid of this because we still wanted this in terms of cosine. There's still sine in there. We needed to figure out how to get rid of it. So, excuse me, I didn't mean to include the 2. So I replaced this with that. Okay, so my sine squared of x became 1 minus cosine squared of x. So I've got 2 times the cosine x, and then I changed that to 1 minus cosine squared of x. And then I'm going to expand that again, so I'm going to distribute that 2 cosine of x between the 2. And now I've got, okay, a cube, but then I have 2 there. And actually this should be to the third, so I've got another cube. So I've got 2 cosine cubed x minus cosine x minus 2 cosine x plus 2 cosine cubed x. So now all I have to do is simplify, combine like terms to get my answer. 4 cosine cubed x minus 3 cosine x. Alright, so we've got the third example now. Let me go ahead and back up for a second. We need to prove the identity sine of 3x over sine of x cosine of x equals 4 cosine of x minus the secant of x. Alright, so to do this, I'm going to work the left-hand side. I'm going to take this and work the left-hand side. And I'm going to go ahead and first I split it up. I split up 3x to x plus 2x. And then I used the addition formula to expand that. Took it one step further and used the double angle formula because you notice now I had that cosine of 2x and that sine of 2x, which I made into these. Okay. And then I went ahead and I split the fraction. So I took this half right here, this plus the denominator, and moved it down here. And then I took this part with the denominator and moved it over there. So I basically separated the fraction out so that we could work with this separately. And the reason I did that is so I could come up with this, because what happens is the 2 sine of x's cancel out. This whole thing cancels out with that whole thing. So all we have is cosine of x times 2. So I have 2 cosine of x, and then over here I've got 2 cosine squared of x minus 1 over cosine of x. And we got that by canceling. Now, this next part, what I'm going to do is I'm going to expand or separate the fraction. So I separated this fraction to 2 cosine squared x minus 1 over cosine of x. Oh, not minus 1. Minus 1 over cosine of x. So this cosine canceled out with one of these up here, leaving me with 2 cosine of x. Subtracted the 1 cosine of x plus 2 cosine of x. This became secant. Combined my like terms. And good to go. So I basically used the reciprocal identity to go from here to here. And last but not least, verifying this identity. So I'm going to go ahead and work with the left-hand side. We've got sine x plus cosine x, quantity squared. We need that to equal 1 plus sine of 2x. So I'm going to go ahead and use FOIL on this and do sine of x plus cosine of x times sine of x plus cosine of x to get this, sine of x plus 2 sine of x cosine of x plus cosine squared of x. And the reason why I got this 1 here is because if you notice I've got sine squared of x plus cosine squared of x. What is sine squared of x plus cosine squared of x equal? That's right, it equals 1. So that's where I got that 1. And I'm left with 2 sine of x cosine of x, which, if you refer to your notes, you will notice is sine 2x. That's a formula, that's a double angle formula for sine of 2x. So 1 plus sine of 2x equals the right-hand side. Now I know this is a lot to take in and a lot to memorize. But the best thing you can do is practice, practice, practice. And really, you will get better at it, I promise. That's the best advice I can give. But if you do have any questions, please let me know. All right? Have a good one.